So we have presenting today Paul Watson from Mononet LLC about enterprise replication. Paul, it's all yours.
Okay, well, we don't have a vast number of people here, but okay, so this is basically a revamp. Sorry, everybody hear me? Everything going to hear me okay?
5 by 5, it's good.
Okay, great. Okay, so this is a revamp of a enterprise replication presentation I did virtually 5 years to the day. So a lot of the slides, if you attended that one, will be very similar. But there are some updates within the system. Right, just getting my end sorted. So Art says then, if you want to chat to me, put it on the chat. Art will interrupt me if there's any questions, and obviously mute your line. Standard, WebEx meeting type stuff. As Art said, Paul Watson, my email's there, my cell number's there. I'm always happy to take calls regardless. I'd rather you didn't wake me up in the middle of the night with something dumb, but most of your system's down in the middle of the night. I'm happy to take a call. So today's agenda is fairly straightforward. We're going to just talk about ER. It's certainly not going to cover everything that ER can do. That is typically a 3 to 4 day course, but we will cover most of the basics. What always makes me smile when I'm doing things like this is I have to go and look up the actual commands that are needed to do ER because I have everything so heavily scripted to make my life a lot easier. So I said, makes me laugh. I have to go and look up the commands for something that I just do via scripts all the time. My personal choice, I much prefer ER over HDR because it gives a lot more flexibility, though I'm more than happy to accept that HDR is a lot easier to set up. So what is ER? ER is async replication to databases that reside at a different site. So replicated after primary database, any changes are replicated on a commit and are pushed across to the other servers. With async replication, the delay to update the replicated database can vary depending on the business application, the user requirements. However, the data eventually will synchronize to the same value across all sites involved in the replication. The major benefit of this type of replication is if a particular database server fails, the replication process can continue, live transactions can continue on the various systems, and when the failed server comes back, everything will just catch up. There's a couple of gotchas around that, but fundamentally, take it, if it fails, bring up the failed server, it will just catch up. Enterprise replication is a log-based data capture it gathers the information for replication. So the enterprise replication reads the logical logs to obtain the raw images for the tables that are part of the replication, and then evaluates the raw images. You can think of replication being built on top of CDC APIs, but I believe it's the other way around. The CDC APIs and process were built on top of the work already done by the ER process. I'm happy to be told I'm wrong about that, but that is my understanding. So there's various topologies here. I'm not going to mention HDR or RSS, but every node that we see here, every database server, target, whatever, can also be an HDR cluster of some description, whether that's HDR and SDS or RSS, it doesn't matter. Just take it as read that when we're talking about an ER server, that ER server could still be an HDR cluster of some description. These images were stolen from IBM, so you might recognize some of them. So as the name suggests, primary target, the top one, is a master server, i.e. one server is in charge. You could call it, private. Sorry, I got myself muddled up. As the name suggests, a primary target server. Again, give me 1 second. I've got a mismatch at this end. I see what's happened. This is a PowerPoint thing. Sorry, guys. Yeah, this is what we're supposed to be. My bad. I was on the wrong screen at this end. Okay, so as the name suggests, primary target. There's a master server, i.e. one server in charge, and this could be called one-way replication. This means we never need to worry about conflicts, so there's no need to worry about what is happening on the right-hand side of the image when the left-hand side is doing something. It's highly configurable. It can do virtually anything you could possibly want it to do, but for the sake of simplicity, I would always try and keep it very simple. Now remember, it doesn't support directly replicating DDL. So if you create a table in a particular server, it will not by default replicate across to the other servers. We'd have to use various grid commands to make that happen. So grid is built on top of ER, but DDL is not replicated by default. Again, these images are stolen from IBM. So we can have a variety of topologies, like I said, and classified of root nodes. Root nodes know everything about everybody. Leaf nodes only need to know about their nearest node. So in the case here, we've got a root node at Dallas. Dallas knows everything about New York, Oakland, Parkland, Lenexa, and Mobile. Probably Mobile. But Lenexa Mobile only know about their root node. So the catalogs are slightly different. So they only need to know about Dallas. There are a number of prerequisites when we're talking about ER. The servers must trust each other. So DB access between the various servers on the replication Informix server you want to use must be bi-directional trust for configuration purposes. I have been told, although I've never used it, it doesn't have to be bi-directional once it's up and running if you're only doing one-way replication. I have not tried that, I have not tested it, but it's what I've been told. The servers must be in time sync. So if the servers are out by a reasonable amount of time, ER won't even start. If they're out and drifting, ER might close down and you'll see warnings in the online log, and it'll tell you the time is getting out of sync. When you're checking the timers in sync, Art might remember this one. A long time ago, we could not get some ER servers to start, and we looked at the timestamps. They're completely in sync. They were reporting exactly the same thing. And that's when we discovered that Israeli Summertime, IST, has the same acronym as Indian Standard Time. So one was running in Indian Standard Time, one was running in Israeli Summertime. The date said it was the same, but obviously the time zone difference meant that they were completely out and that we just could not get ER to synchronize and start up. I always recommend you run the ER under UTC. You don't have to worry about time zone changes. You don't have to worry daylight saving, just run in UTC. You will also have to configure some CDR-DB spaces, which we'll get to in a few minutes. We have to configure the SQL host file, which is should be relatively obvious to everybody, that we have to explain how the grid, how the replication topology is configured. Table requirements, we need a primary key or unique key on every table. And we might need to deploy ER keys, which we'll talk about, CR calls, which we'll touch on, and REPL check columns. We'll talk about them, more about them later. Within the onConfig, there's a number of variables. The important ones, probably CDR queue memory. Defaults to 4 meg. The recommended size you see on the screen is about 30% of the logical log size. You can make the CDR queue memory too big. If you get it ridiculously large, it spends a long time managing that memory, where it could obviously be off doing better things. We need a CDR DB space. I'm jumping around a second off the bottom. CDR DB space, so that's where syscdr will live. It will default to root DBS if you don't have CDR DB space defined. And unlike the database sysadmin, you can't move it once it's up and running. So if you need to move it, you can't without dropping and rebuilding the CDR system. So you want to make sure that's set. The CDR database, syscdr contains all the header information that's needed. So contains all the control tables that ER needs. So when we have replication, we have queues. The queues contain the data that will be replicated out to the system, and they live in CDR queue data SBS space. You really do have to have one minimum, needs to be logged, and one non-logged space. Typically, I would normally set that up with 4. If you're migrating up to a later version of Informix from an older ER system, you might see you have CDR queue header DB spaces, and those were used to contain the tables that had the header information for every queue. I believe that is no longer a requirement, but if it's in an existing system you're migrating up to 14, I can't comment on 15, they will need to be there. CDR serial, you only need to worry about if you're inserting into multiple servers in an update anywhere situation, to make sure the serial key maintains its uniqueness across the entire ER cluster. So if we've got 3 ER systems, we insert into server 1, the CDR value might come back as 1. If we do the same insert, again, we'll get 2. We're replicating across the system, and we can get conflicts. So what happens is CDR serial allows us to, in the 3-node situation, server 1 would insert 1, 4, 7, 10, etc. Server 2 would insert 2, 5, 8, etc. Server 3 would insert 3, 6, 9, etc. If you think your CDR, we did this with a deployment a few years back. We were only deploying to a 3-node cluster update anywhere, but they knew that they were going to bring in more servers online, more clusters at a later date. So we pre-configured CDR serial to cope with the fact we were going to have a 10-node cluster rather than existing 3. We just got ahead of ourselves on that one. Otherwise, you'd have to go back and change everything. At least now, as I'm aware, CDR serial, we can actually change on the fly. If you do get bad serial data type conflicts, it's always worth double checking CDR serial is actually set correctly. The SQL host file. So a very simple example here, normal traffic on this machine. I've got 2 servers defined, Theoden and Gimli. I use Lord of the Rings characters because I don't get out very often. And then we've got replication traffic. So we've got, so the top half, like I said, would be normal traffic. I combine this into one SQL host at the lower half. So we can see a group G_Theoden. So that's the name that the ER will use. You can see it's defined as a group, a couple of dashes, I = 1. So it's the first cluster is 1. When we parse the replication, so the SQL host file, we are telling it, the E is saying, once you get to Theoden_REPL, don't worry about the rest of the file. We don't have to worry about it. We don't care about it. I don't know when that came into place, but it was, it just makes a very, very large SQL host file. It makes the processing the file a lot quicker. And if we look down here at G Gimli, we'll see I = 2. That I number must be unique across the entire cluster. And now what we've got here, we've got the replication traffic running over normal socket connections, and we've got the SSL traffic for real world. Real world traffic is going across SSL. So when we come to get started, we have to define our first node, and that's the first line we've got there. CDR define server connecting to the Gimli server, so that is going to be our master. We're connecting on the Informix server, not the group. We're specifying ATS and RAS files, which are basically debug files when we have problems with the data. And we're initializing we're initializing a ER server called G_Gimli. The second line, we're now adding the other node into this cluster. So we've defined a server C Theoden_REPL, same A and T options, A and R options, sorry. We're calling this server the source server G_Gimli, and we're initializing G_Theoden. So we'll end up with a 2-node cluster here. I do a CDR list server, and I see both servers connected, up and running, and happy. Once had a problem when they couldn't get their CR customer rang in, they couldn't get their ER cluster to define, and they hadn't, one of the servers was offline. So I thought it goes without saying, the servers must be up and running to do this, but customer decided that they didn't think that was a requirement. So the server must be running. Like I said, it's obvious, but it caught the customer out. So now we have to define what are we going to actually replicate. So the first one here is an update anywhere replication. So we're defining a replicant. We're telling the C tells it to ignore any conflicts. We're telling it who is the master, who's in charge, for want of a better term. We're giving it the Theoden on it. Nagios is the replicant name. And then we've got 2 SQL statements. On in it, add Theoden in the table. And what are we actually doing? We're selecting star from Nagios. And then we've got the other participant in this replication. And we're doing another select star. The second one is one-way replication. Primary target. So updates, the P specifies primary, are read only probably. I don't know, I've never really thought about it. So this is any update in the customer table will replicate down into Gimli. Any update in the customer table on Gimli will not replicate back up the way. We see a couple of comments here, a couple of options on the line. We've got a -ER key. So this is a table that doesn't have a primary key. An ER key will give us a fake primary key, more of which we'll chat about later. And this time we've used the longhand to say conflict. rather than the -C, we've done /conflict. Now, these are both being defined as what we call classic replicants. The select star tells me it's a classic replicant. By default, we define now a master replicant. And under a master, that star would expand out to a column listing. When you do a CDR list catalog, it will not tell you in the CDR definition whether it's a classic or a master not from the catalog. You'd have to go into system tables and look it up. But basically, if you see a select star, it's a classic. If you see a select column list, it's a master. And honestly, I do not know why they did it like that. We have a scope option there. So the scope is when we apply a transaction. So most of our transactions hopefully are going to be multi-table. So if we do an update to 4 tables and the data is sent across to the remote node and there is a problem, what do we want to do? So if we have a scope level of transaction, it is saying apply every update to every table, and if it fails, roll back the entire transaction. If we have a scope level of row, it will apply the changes to the table, and if there's a fault in the table, say a referential key missing, it will just ignore that and keep going. Now that is very useful. Say again.
Paul, you got a question.
Yep.
I'm sorry, my mic wasn't working a minute ago.
Yeah.
Desmond.
Yeah, I'm not aware of doing that. Honestly, I don't know. I think if you did a CDR modify, that might work, but I don't know. I really just don't know. It's not. I've never gone out of my way to define them as classic or master. Just define them, and typically they are masters, but I don't explicitly do that. And I think even if you do a select star as your definition on the top line there, that will expand that out to be a master, unless you tell it to define it as a classic. That is my understanding. Does that answer your question, Desmond? Yeah. Well, he said yes, so I'll believe him. So coming back to this row level, scope level transaction or row. So if you're doing something like I'm involved in a project at the moment, we've got about 2,000 or 3,000 tables that we're consolidating down into a reporting system. Of those 2,000 or 3,000 tables, we only need a couple of hundred of them. But when the live system does an update, it's applying a transaction to some tables that are not within the replication system. So when that transaction is pushed down to the remote node, some of the tables that are involved in that transaction just don't exist. So that if we have a scope of transaction level, it will not apply any changes. So in this case, we want row level scope. So the rows that are trying to insert into the table that don't exist will just be silently ignored. The nice thing about using the master as well, because you've got a list of columns, it's very easy to go in and take out columns you're not interested in. So again, in the example I'm working on, a customer I'm working at the moment, we do not want to replicate any of the text fields, any of the blobs. So we just edit the column listing and take out those blob fields. Okay, and then obviously, having chatted about that, we now have a slide telling us about that. So conflict tells us how to, what happens if there's an issue between the data at one end compared to the other. Always is exactly what it says, always try and apply the transaction. Ignore basically says, do not try and resolve any conflicts, do the best you can, things might or might not roll back. Timestamp, as the name suggests, the row with the latest, the change with the latest timestamp will win. And delete wins is useful because it prevents upsert operations. So if you're trying to delete something that's already there, it will not try and convert it. A couple of neat options. If the tables don't exist on the target, they will be created. Again, like I said before, I have scripts to do all this, so I very rarely use the -u because within the scripts, it will check that the table is there and automatically create it if required. But that didn't exist back in the dark ages, it does now. You can specify which columns you want to use as a replication key. So when we're doing the index stuff, if you've got multiple indices there, primary key will be picked up by default. But if you don't have a primary key, it will try and use a unique index, and you can tell it which index you want to use. By default, we don't fire triggers. If you think about it, we are replicating the entire table, the entire database, and we've got a table, sales order, for example, and we want to, within the sales order on the live system, we will trigger an audit record of what's happened into the audit tables on the live system. When we push that record down to the ER system, by default, that audit trigger won't fire because the audit table is in the replication, so those records are being pushed down already. But you can get situations where you want to fire the trigger on the target, and you have to specify the -T or -- triggers, and it will cause the trigger to fire on the target. By default, they do not fire. Oops. So having defined a replicant, we have to start it. Replicants, back 2 screens. Sorry, wrong window. 3 screens. So that there has defined a replicant, but it doesn't start. So that replicant, although it's defined, is not physically running until we actually start it. And then you can do a list of the replicant, and it'll tell you what's happening: primary, Informix, suppliers, master, etc., etc. We're doing transactional level, full row. If you're using CDC to scrape the data of a third-party application, I believe you have to have full row replication. Another interesting one here is frequency. ER is capable of running various frequency options. The default is immediate, so a transaction applied will be replicated and applied on the target server. But if you think about a situation where you might have bad comms for periods of the day, you might want to delay the replication traffic until your comms are faster or more available, or even just available. You could also use it a bit like you do under an RSS node, where you've got a delay apply. So the RSS node is running 20 minutes, 30 minutes, whatever, behind the live server. You can do much the same with ER and just tell it, apply these transactions 30 minutes later, and you have a recovery window if you want to pull back data that might be deleted in error. You can now do, sorry, this here, the replicant ID. I argued for hundreds of years with Madison that we should be able to query and use the REPL ID directly on the commands. He always said it was a waste of time, but I believe you can do it now. I think you can do CDR list REPL, and if you give it a REPL ID, it will work. When you're having errors, nearly all the errors will return the REPL ID and not the name. And then you have to go and cross-reference the REPL ID to find out what it is. I believe that has been fixed, or enhanced, whatever the word is. So we've got a cluster defined. we've got a replicant defined, we've started the replicant. How do we know it's actually doing its job? So we can run a CDR check command, CDR check REPL. So we are going to be connecting to a server. We're going to say, so we're connecting to Theoden here. We're telling it Theoden is the person in charge. The -R will tell us what replicant name we're using. And for the purposes of doing the check, we're going to have a -N, and we're going to give the job that's doing the check a name. It just means it's easy to find later. And when that is finished, it's come back and told me I've got 1,453 rows missing. Now, depending on the system, that might be acceptable. If you imagine this is a very busy system taking a lot of transactions, the one thing you can probably guarantee is your tables are out of sync. We will always have in-flight data. I know Art and myself, we've worked on systems where our in-flight data was measured in millions of transactions. So the server is millions of transactions behind the primary. But if that table is not seeing any active traffic, you would expect those rows to be 100% in sync. They should be 100% in sync. If we want to check the replicant, which we've just done, we found 1,453 rows are out or missing. We now want to repair it. So we have a -R or a -- repair option, and it will fix the replication. So it will make sure that Theoden's data is 100% in sync with the Gimli data. For those of you who might have attended this presentation before, I said the CDR sync option was being deprecated. That was not the case. The CDR sync is still a valid option. So why would you choose to repair a replicant as opposed to resync a replicant? So if you think about the situation here of our 72 million rows, we've only got 1,400 and change rows missing. So it's quicker for us to find those rows and repair them and synchronize them that way. If Gimli only had 1,000 records or 0 records, it's quicker to tell it to synchronize the whole table, and the underpinning mechanism is slightly different. So synchronizations, when you have a vast delta between the two ends, is the way to go. A repair if the delta is only minor. If you're still in version 12, I have noticed the synchronization process can be visible to the application layer. So the application layer can see locking issues. I've never seen locking issues visible to the application layer using a -R. They might be visible to the CDR check. You might get some locking issues occasionally, but they're generally not visible to the application layer. Also, a synchronization, especially on large table sets, is significantly faster, orders of magnitude faster. I'm currently repairing a table in the background here as we've been chatting. It's got about 150 million rows, and the repair is going to take 2 or 3 days. The synchronization would take a couple of days, but like I said, that has the potential to be impactful on the live data. So that's why the decision was to repair rather than resynchronize. Once you've got this job here, we can see we've run a repair job, and the -N is giving us a name. So now we can look at CDR stats check, and the name would appear there. And we're running CDR, we're checking an R2. So it refreshes every 2 seconds, and it'll tell us where it's up to in the job. If you're running a synchronization job, you'd use CDR stats sync. The remaining time is accurate-ish. If you kick off a large repair, it might say 10 hours and you think, oh, I'll come back in 10 hours time. You wait 2 or 3 minutes, check again. It could have gone up to 1,000 hours, or it could come down to 20 seconds. Again, I remember chatting to Madison about this, and he said, just don't believe it. I believe it's more accurate now. It's accurate-ish if you've had it running for a while. So if you start off a sync job or repair job and it says 4 hours, check again in a few minutes time. If it's still saying 3 hours and 55, it's probably going to be 3 hours 55 before it's finished. Give it a little time to adjust and recalibrate. If you're running a job, a stats job, a check or repair job on the remote server, you will have to use a -C option to connect to the remote server, because the job is being run on the remote end, not the target end. So it's all well and good having all these ER systems. We've got all these replicants defined. How do we get the initial data from server A into the remote host? Basically, we've got 3 options: on tape or on bar. We do a restore. We could do, if you've got an HDR server, you can convert that to an ER secondary. I know it's doable. I've seen it done, but I've never actually done it myself. And CDR Migrate came in within the last few years and allows you to migrate the live data into a remote node. It is very, very fast. It uses raw tables to do the work and the heavy lifting. I have never used it in anger, so I can't comment on it in the real world, but it will move terabytes of data around very, very quickly. Whether it's impactful on the live server, I don't know. Like I said, I've never used it in anger. And that's really all there is to it. You define a server, a cluster using SQL hosts, CDR define to define the topology, CDR define replicant to say what you're replicating, CDR start to start the replicant, and the checks to work out whether it's all running smoothly. Now, I never use them, but you can also do replicant sets. So you might have a set of tables that belongs to sales ordering, and you might have a set of tables that are involved in inventory, and you want to pause or start replication. So you could define a replicant set of sales and a replicant set of inventory, and stop and start all the replicants within that replicant set. So let's just say you've got 30 replicant tables replicating in sales order. So we create a sales order replicant set with those 20 replicants in there, and you can stop and start them that way. I've never used them. Like I said, I can't comment, but I know they're out there. Table requirements. You must have a primary key or a unique index or an ER key. And in order of priority and preference, that's what you want them to be. Or I would always argue, unless the table is absolutely tiny, always add a REPL check. The REPL check we'll get to a little bit later on, but I would always have a REPL check column. We will touch on this again in a while. The manual states the REPL check column is a checksum on the row. The manual lies. We'll come back to that in a bit later on. Some of the common gotchas and tips. Do not, on an update anywhere system, just drop syscdr. If you do, you really want to recycle the engine, because it leaves memory structures lying around. The recommendation has always been from IBM, you run a drop CDR delete server. Don't just drop syscdr unless you're in a situation where you can recycle the engine. If things aren't running as well as you think they should be, always blame the target, not the source. So if you're replicating 1 million rows and it appears to be very slow, start with the target and work your way back. When you're running a CDR command, you can export mytrace equals 1, and it will show you the SQL that's been run, and it will give you the statements that have been run if they're available. When I say designate a master, what I really mean is not a master node or anything like that. Get into the habit of running all of your CDR commands from a common server. You might SSH into another box to do something, or you might use a CDR with a connect to a remote server. Get in the habit of running everything from a common point. That common point should be running the latest version of the CDR software. CDR is just a binary. So sometimes if you're hitting problems, you can copy a 1410 dot whatever CDR binary down into a 12 engine, and it will quite happily work. The reason you want to run CDR from the latest version of the engine is it knows the limitations of the lower tier. So a CDR 14 binary will understand that it can't do certain things when it connects to a 12. A 12 binary has no idea what 14 is. So it'll throw commands up there that 14 might or might not accept. You can't have too much log space when it comes to ER. It's a log-based replication. I don't have a slide showing this, but we have a thing called DDR block, which basically, when ER can't keep up, the engine has the potential to hang until it has caught up. And the way around that is to have a huge amount of log space. Avoid very, very large transactions. Very large transactions is not what ER was ever designed for. ER is exceptionally good at pushing small amounts of data across the system very, very quickly. It does not like large transactions. Unstat is your friend. Everything you'd possibly want to know about ER and what it's doing is available under some sort of unstat option. Coming back to avoid large transactions, there's two types of large transactions here. There's a large transactions that we know and love that will cause long transaction rollback, whatever that error is, I can't remember. And there's ER long transactions. If you run an unstat -g grp pager, it will show you if ER has seen work it considers to be a large transaction. And again, you want to avoid them. If you have to update a 200 million row table, you're better off dropping it out of replication, apply it on all the nodes and bringing it back up, or apply the update in smaller parts. Upgrades. So if you're upgrading your engine, that can cause you some issues. Yeah, again, that will do this. Someone to put on the chat, you can do it with replication without, begin work without replication as well. So it's up to you how you want to do it. Logically, personally, I think logically it's the same thing. Drop the replicant, do the change, come back. It depends whether you get the table level outage or not. Very large updates tend to be done out of normal business hours at that level. So yeah, I accept the fact you do a begin work without replication. If you're doing an upgrade between 12, 14, 15, you might have to convert the syscdr database. There are in Informix etc conversion scripts to run that. Yeah, check, like nobody ever does, check your release notes. ER and REPL check are slow alters, which are an unbelievable pain. There are talks about making them not slow alters, but we're going to touch on those in a second, ways to get around the fact they're slow alters. Sorry, my machine at my end is just locked up. Give me a second. Adding the additional columns, particularly ER keys and REPL check, can take forever. You need a table level lock, and they can cause an LTX. So you try to imagine you're adding REPL check to a multi-million or even billion row column, then you need a lock on the table. It's a table level rewrite, so you need huge amounts of space as well, and you can hit an LTX. So what we want to do is do these changes as an IPA, which can be done via a couple of back doors. There are talks, I've spoken to Nagaraju about this in the past, whether they're going to implement these as IPAs, and I don't know what the state of that is. The other thing, when you, it's not so important now, especially under 15, but if you have a table, when you add these extra columns, you might end up blowing through your 16 million row table limitations, because we're adding these extra columns. We make the row larger. We might run over the 16 million. So neat tricks. ER key is the easiest one. Alter your table. You add the 3 columns that Informix expects as normal tables. That is an IPA. So those tables are there. Momentary table lock. Nobody will see it, notice about it. Problem now is we can't use that as an ER key because all of them are zeros. So we have to populate it. And again, that's relatively straightforward. All you have to do is step through all those 3 keys and make sure that each one of those is unique. And it's fairly straightforward. We're just stepping through, incrementing the value, 1, updating the table, increment the value, update the table. We got a transaction size there towards the bottom of the screen of 1 million, so we're doing 1 million passes a time. When that's finished, we will have a fully populated and usable set of ER keys on the table. Yeah, people will notice that I've actually called them Informix ER key there, and I've actually selected them as a different name, but no, I'm sure you would have worked that one out. Okay, so now we have to convert that ER key into a real key. So we do need a lock at this point. So we got to lock the table exclusive. We have to create that index. So you could create the index outside of this, unless you could break this down into separate steps. I tend to do it in one. So we've created our ER index, and this time, because it's large, we've fragged it across multiple DB spaces. Okay, we've altered the table, we've added the primary key. And the clever bit is this. So we're now telling the database that these ER columns we've created are ER columns. So that's what that does. 17, 13, 25 of the column attributes, and off we go. And that will now have converted without any serious outages. We've added an ER key into the system. We can do exactly the same with REPL check. We add a REPL check column, a big int. Then we have to update the sys columns and telling it it's a REPL check column. The gotcha here is REPL check's quite important. It's what the database uses to check the consistency of the rows. I'm getting tight on time.
Yeah, it's getting a little tight.
I'm happy to keep going if people want me to keep going, or we can. I'll keep going as long as people are interested. Basically, I mean, if they're all bored and left, that's fine.
So I assume anybody who's got a time constraint will drop off, and we'll just keep going.
Okay, so REPL check. Add the column as a normal in place IPA. Update the column, and we've got a REPL check column set. So Imagine this is, it's close to instant. We know what IPAs are. Right. According to the manual, okay, what we then, to populate that column, we use something like IFX checksum function, and we IFX checksum all the various columns till we come up with a value that we can update the REPL check to. That is absolute and utter rubbish. The manual is wrong. Okay, the IFX REPL check column is a compound column. They do not and have not, despite numerous requests, documented. There is a combination of a checksum in there and also a timestamp. I believe the upper byte are the timestamp and the lower byte are the checksum. So you don't have to go out all the hassle to actually populate this column. You have to make sure it's non-null. So you do want to make sure it's non-null, but you don't have to populate it as if it's a real column. Now I don't think I've got a slide on this, but imagine you got two tables. I know I haven't got a slide. Imagine you got two tables. You've added REPL check to table A, and you've now decided, you've gone through and you've made all of the REPL check columns 42. Yeah. Then the database is continued and it's updated some of those columns, so they've now got a valid REPL check column in them. I now want to replicate that table to another node. If the table schema is identical with the IFX REPL check column as a real column, I would do an unload and load it in. So my 42s that are populated on the live table, the last thing Informix will do when it loads it in to the new table on the remote node is calculate what the proper checksum should be, or the proper REPL check should be. So my 42s will become this horrendous big int number. So if I want to do this approach, I have to make sure the IFX REPL check column on the target during the load process is a normal big integer. And after the load process, I can swap it back to column attribute 9, which now means the rows I know are good that had a REPL check of 40 will exist in the target with a REPL check of 42. And when we compare the rows, it will say that they are identical. If I don't set the column to a standard big int during the load, the IFX REPL check will be regenerated. You do your comparison and all your rows will be out. Hopefully that makes sense. No one's saying it doesn't make sense. So I'm going to assume that all makes sense. And that's it for me. I mean, I've only marginally gone past. I'm open to questions. I haven't touched on CR calls and ver calls. Like I said, this is just basically an overview of ER in most of my environments. The thing I didn't mention, you always want to have an index on the primary key or unique index or ER key and the REPL check. Adding, it's easier now, but find the ER key where if you create it manually, create it automatically by the engine, find the ER key and move it out of the ER key index, move it out of a standard database space and move it into your index DB spaces, fragmented if you need to. The other thing that's not mentioned on the slides, and I only found out the other day, no matter what your PDQ environment is set to when you start a CDR command, it will ignore it. It will always set PDRQ priority back to 0 within the application, which is a nightmare if you want to. You've got a billion row table that's heavily fragmented and you only want to look at one particular fragment. CDR will just completely ignore all that. They haven't come up with a good reason why to me. And like I said, that's it from my point of view. Anybody got any questions? I put them in the chat or pester Art and he can open up the microphone and we can go from there.
The only thing I would add is the latest thing added to ER in the latest versions of 14 and in 15 is cascading updates. Cascading replication. So you can replicate from server A to B and then from B to C, which you couldn't do before originally. That's the latest addition to ER.
Okay, so this would come up in, I had this problem. I have an ER cluster of 3 nodes, which I want to replicate down to a warehouse. And I think what Ars just said would fix the problem. So I would, my staging node would replicate to the primary server of these in the ER cluster. The ER cluster, if I updated a different node, it would update to the primary node of the cluster, but that update would not, as Mark just described, cascade down to the DB stage server or the staging server. So we had to add, I had to add staging server into the primary ER cluster. So that becomes a 4-node cluster, and then various other machines come into, but cascading updates would get rid of that. I believe. Right. I haven't tested it.
That's the idea, yeah.
The other thing is if you're on if you're not on a later version of Informix, which is basically anything 14.10 FC6 and earlier, I don't know the 12 level ones, when you got very large ER queues and data in flight, the processing of those queues is very, very slow. You need to be off that version. The other thing is if you are doing CDR commands on a server that's very busy, they go into a control queue and they get pushed around faster. Do not trust ER to know what it's doing. When you issue a command, it will go onto the control queue and it will be processed. If you have a very large queue, like I said, pre-FC6, that could take a while, but give it chance. If you try and second guess it, you will probably end up breaking something. ER is incredibly robust and incredibly powerful. Just trust it. I mean, I know none of us trust IBM, but trust ER.
All right.
Anything from anybody else?
I don't see any new questions. So unless somebody's got their hand raised and I missed it.
You've all got my email. Yeah, everyone's got my email. So pester me if you've got any questions.
All right. Thank you, Paul. Thanks everybody for attending. I'm going to stop the video, the recording, and then we'll shut down. All right. Thank you. Bye.
Okay. Cheers, Art.